The statistics of birds that are Canadian geese in the 1900s were very high flying over New York, but steadily they have gotten lesser and lesser. You know why? Because the birds are dying. The birds are dying, therefore their statistics are regressing.
Allie, what is a regression?
Regression is when something gets worse.
What is statistical regression?
I don't know. It's infinite backsliding.
What is statistical regression?
I have no idea.
Get it out and then
Statistical regression. Let's see. It's on the tip of my tongue.
What is statistical regression? Hey Abby, what's a statistical regression? What did the drains have said?
It's seen in the deer population. Hunters target bucks with big antlers, so their breed dies out.
And that's regression?
That's statistical regression.
No. A regression is a statistic which allows you to compute the percentage of variance accounted for in the dependent variable with all of the independent variables.
Independent variables, or IVs, are also called predictive variables, and they're associated with the dependent variable, or DV, also called the output variable or criterion variable.
In a regression, you're looking for a relationship between the dependent variable and all of the independent variables. You're also looking for the direction and the strength of the relationship.
Regression also allows you to see which of the independent variables are the most significant in impacting the dependent variable.
Remember, regression assumes non-multicollinearity. Multicollinearity means that there are correlations that exist between the independent variables. If the independent variables are too highly correlated, then you can't really see which one has the best relationship with the dependent variable.
There are 4 types of regression: simple, multiple, logistic, and ordinary least squares regression, or OLS. A simple regression has only one independent variable and only one dependent variable. An example of this is how depression, or the DV, is associated with cigarette usage, or the IV.
Multiple regression has multiple independent variables, but only one dependent variable. Stay tuned! There will be more detail on this regression later. A logistic regression has a dichotomous dependent variable and has continuous or dichotomous independent variables. When reporting a logistic regression, you need to make sure to include odd ratios and a chi-squared statistic.
Ordinary least squares regression, or OLS, is a method for estimating the unknown parameters of a linear regression model. It minimizes the difference between the slope of y and y prime. The equation is y prime equals b multiplied by x plus a. In other words, the predicted dv equals the slope times observed IV plus x-axis intercept. The confidence interval must be reported, and this shows how sure we are that our line reflects reality.
There are 3 methods of entry for regression. The first and most common is the enter method, also known as the standard or direct method, which means you enter the data into the equation all at one time. The second method is the hierarchical or sequential method, which is user-determined.
Lastly, there are 3 data-determined methods of entry. The first is the backward model, in which all the IVs are included in the equation, but they're taken out one by one based on small significance. The second is the forward model, in which none of the IVs are included and they're added in one by one based on largest significance. The stepwise is the last, in which none of the IVs are included, and they are added one by one or taken out one by one. This is also called the unwise regression.
Here we'll show you an example of a multiple regression using the enter method and the 3 statistics that must be reported: the R² value, the ANOVA statistics, and the beta or the B coefficients. In our example, the dependent variable is a teenager wetting the bed. The independent variables that could be affecting our dependent variable are your hand being dipped in warm water, having bad dreams, having a new baby in the house, having a mental illness, or having a neurological disorder. In a multiple regression, the coefficient is R². In this case, as you can see, the R² value is equal to 0.151, which means that 15.1% of teenagers wetting the bed is accounted for by our 5 independent variables.
An ANOVA is used in a regression to make sure that IVs are not related linearly to the DV in question. The null hypothesis it tests is that the slope of the regression line equals 0. This is also called the omnibus statistic. An alternative hypothesis states the slope is not equal to 0. We report it using capital and italicized F, parentheses, degrees of freedom, comma, degrees of freedom, equals your F statistic, and then you report significance.
In our example, the ANOVA for our regression shows us that capital italicized F, parentheses, 5, comma, 92, parentheses, is 3.264, with P equaling 0.009. This means that our results are significant, and the slope of the regression line is not equal to 0. So our null hypothesis can be rejected.
A t-test computes beta or B coefficients, which describe how each individual predictor, or IV, relates to the outcome variable, or DV. Betas are expressed in units of standard deviation, while Bs are non-standardized and are expressed in original units of measure. When you analyze Bs or betas, you only have to analyze one of them. Here we'll analyze the betas.
Here are the beta coefficients for our multiple regression.
As you can see, in our analysis, for every 1 unit increase in standard deviation for your hand being dipped in warm water, there is a 0.8 standard deviation unit change in wetting the bed. Like all statistical analyses, there are some strengths and weaknesses with regression. Some of the strengths of regression include that you have more control over each of the variables that you're testing. You can also test the independent variables as a whole and as separate factors influencing the dependent variable.
But the more variables you have, the more likely multicollinearity will occur. Another weakness is the regression cannot claim causality, meaning a regression can't determine why this variability occurs.
Thanks for watching, and good